Hi guys, this is your DK again. Welcome to the next video towards learning OpenCV. In this video, we are going to discuss about image segmentation. So image segmentation is something categorizing the objects based upon the criteria. So let's see the difference between object detection and image segmentation. Here you can see, right? Object detection is something like detecting the object. But in image segmentation, we are going to categorize the object based upon the criteria. You can see over here, all the goats has been categorized as blue color and the dog has been categorized in red color. So this is called semantic segmentation, and we do have something like instance segmentation where each and every goat is categorized by 3 different colors. So in this video, we are going to see from the scratch how to perform image segmentation using OpenCV. Now let's see how the image segmentation can be done using OpenCV and other Python packages. So here I'm going to import the basic packages like NumPy, OpenCV, Matplotlib and SkyPy. So I'm going to run this piece of code. So I'm going to use Adoni's image for the image segmentation. So I'm going to read it actually. So I'm going to read it using plt.imbreathe. So this is showing the image. So basically we have already seen, right? So yeah, colored image is of 3 dimension. It has a red, green and blue. If you don't know about it, kindly do revisit my previous video. So we are reading the image, so and we are converting into an grayscale image. Since grayscale image will be of a 1 dimension, so that's what we can see. It is a 1 dimensional image of 605, 806 matrix. So I'm gonna convert this 2, 2 matrix into a single dimension. So that's what I have done over here. So what I'm gonna do is like I'm gonna multiply 605 into 806, and I'm gonna reshape this 2, 2 cross matrix into a single matrix, which is like 4,87,630. So I'm just running piece of this code here. So what I'm gonna do is like in this particular dimension, I'm gonna get the mean of overall pixel. Okay, let me show you the values of this one. I mean, we can insert a new column and we can see the values of this one. So if I try to print gray, so it will be some pixel of arrays, right? Like 21, 21, 165. It varies from 0 to 255. So what I'm going to do, I'm going to take the mean. So the pixel value less than mean, I'm going to make it as 0, which is greater than mean, I'm going to make it as 1. That's what I have done. I have already ran this piece of code. You can see, right? So it is doing some basic segmentation of it is splitting an image based upon the pixel dimension, like pixel size, which is less than mean, it is putting it as a like black color, and which is greater than mean, it is making it as a white color. This is a basic segmentation. So now what I have done is like we're going to discuss about edge detection. So in the last video we have seen what is the canny edge detection, but we didn't discuss the mathematical insights behind it. Now we're going to see how to perform a simple edge detection. Imagine this is my original image. So you can see, right, some 20, 20, 20 and 10, 10, 10. This is something kind of a pixel. It is a 6 cross 6 image. So you can clearly see like this is this piece of box. This 20 is one color and this 10 is another color. The same is given below. So this is of light gray color and this is of dark gray color. And the difference between 20 and 10. So this is the line. This is the edge actually. So this is something like a vertical edge. If I want to identify this vertical edge, what I need to do is like I need to multiply the real pixel image, which is the 6 cross 6 image, which is below, with this particular kernel. Kernel is nothing but a matrix. When I multiply this number with this number, I'm going to get resultant number something like this. So here you can see, right? So 0 is on the left hand side on both the sides and 30 is in the middle. So which means this is the edge over here. So this dark color line we can easily identify when we multiply any image with this particular kernel. So what I'm going to do is like we already have a kernel shape for identifying. This is for identifying your vertical edge, and we do have similar thing to do the same for horizontal edge detection as well. So what I'm going to do is like this is my vertical edge detection kernel. So I have printed it over here, and this is the horizontal edge detection kernel. So I'm dynamically creating this matrix. So what I'm going to do is like I'm going to read the image. Already I have read the image, right? I'm going to multiply it actually. The original Dhoni's image, I'm going to multiply it with this particular matrix. So as we saw in this example, when we multiply, we are getting a resultant number which is giving you the edges. Similarly, when I multiply with this number, it should give me the edge of the image. So you can see over here, right? So it is doing the vertical and horizontal edge reduction based upon the matrix multiplication. So edge reduction is basically nothing but a matrix multiplication at the end of the day. So it is identifying the horizontal and vertical edges from this piece of image. That's what we are seeing over here. So now let's come into the other thing actually. So we do have another Laplacian smoothing also. I'm just multiplying. It is giving some exact multiplication. So when you multiply with this Laplacian kernel, it will give you some like a clear cut of the edge reduction. On top of this edge reduction, you need to multiply this one. Yeah. Then what I'm gonna do is like I'm gonna read the image and I'm gonna divide it by 255. This is nothing but reducing the magnitude, or it's like a min-max scalar or standard scalar. Those who know about the machine learning could have heard about this term. So we are going to read the image and divide it by 255. So all the image size will come lesser than 0 to 1, something like this. So it is a real image. So now what I'm going to do, I'm going to reshape the same image as shown above. And what I'm going to do is like I'm going to perform k-means clustering. So I'm going to perform k-means clustering on this piece of image, and I'm going to give the cluster size as 5. When I give cluster size of 5, what it's going to do is like it is going to group the pixel size accordingly. So the pixel which looks similar will be grouped into one cluster. Pixel which is looking different from the previous one will be grouped into other cluster. This is nothing but a simple k nearest neighbor concept. So when I apply this piece of code on top of this, and you can see the result over here, it is able to segment Dhoni's image perfectly. So since I have given number of cluster as 5, based upon the 5 cluster, it has segmented Dhoni's image, and it has segmented the ground, and it has segmented the board behind it, and it has segmented the audience image also behind it. This is how we can do a simple segmentation using a k nearest neighbor concept, and we can use RNN also for the better implementation. So that's it with the today's video. Thanks for watching the video and happy learning. If you do like the video, like and subscribe the channel for more upcoming videos.